Okay, so for this short lesson, we are going to go and review the exponent laws that you will need to know and use till you are in grade 12. Right, the first law of exponents is a to the m times a to the n is equal to a to the n plus. Right, so what this law is explaining to us is that if the base, remember, if we have, let's just do some revision quickly. A is what we refer to as the base. Okay, the m is the exponent. And collectively, they are known as a power. See, let me just draw that again. Right. It's not working so well today. So this is referred to as a power, okay? So the first law is where we have two bases that are the same, we have to have the same base. If we don't have the same base, we cannot add the exponents. All right, so an example of that, or seeing this law in action, is if we had x squared times x to the third power, which is cubed, all right, we would then have x to the 2 plus 3, which is the same as x to the 5. This can also extend to numbers that are raised to indices or exponents. If I had 3 squared times, now remember I can display the multiplication of two numbers using either a multiplication sign or just a simple dot like that. 3 to the 2 times 3 to the 3 would equal 3 to the 2 plus 3, which is the same as 3 to the 5. Okay, and that is the first law. Our next exponent law is where we are dividing exponents. So if we have a to the m over, so this is represented as a fraction, and remember that as a fraction, this can also be written as divided by a to the n. Okay, it means the exact same things. This is used interchangeably. So what that means is that when we are dealing, or we are going to be doing problems or questions that have fractions in them, we are going to remember that we are dividing them. Okay, and we're going to then apply the law, which says that if the bases are the same and we are dividing one power by the other, that we have to subtract exponents. So if I had x to the 9 over x to the 3, this would equal x to the 9 minus 3, okay, which is the same as x to the 6. Okay, now let's do an example. If I had a base, rather, or a number. If I had 2 to the 5 divided by 2 to the 3, this would equal 2 to the 5 minus 3, or 2 squared, which is the same as 4. Okay, and that's the next exponent law. Let's do the next one. The next exponent law is where we raise an exponent or a power to another exponent. Okay, so if I had a to the m and I raised it to the n, this law states that if we have a power raised to exponent, what we do is we multiply both these exponents. So this becomes a to the m times n, which can also be written as a to the m n. Okay, now let's see how this works. So if I had x to the 2 cubed, this is going to be x to the 2 times 3, which is the same as x to the 6. If I had a situation where, now here brackets are going to come into play, and we have to be very careful in identifying what is in the brackets and what we are raising to the new power. So if I had 4x squared and I was raising this whole term or power to the power of 3, I have to raise the 4 as well as the x squared to the 3. Remember, the exponent here is 1. That's how 4 is 4. It's 4 to the power of 1. So this is actually 1 times 3. 4 to the 1 times 3 times 2 to the x to the 2 times 3. And this is equal to 4 to the 3 times x to the 6. And 4 to the 3 is 4 times 4 times 4, right? That's what 4 to the 3 is. It's 4 times 4 times 4. And 4 times 4 is 16, and 16 times 4 is 64. So our answer here is 64x to the 6. Now, I can also have a situation where, or you will see that you will end up or do questions where we might have 4x to the squared raised to the power of 4. Here, the 4 isn't in the brackets. So this is non-inclusive, or we are not going to raise the 4 to the power of 4. Okay, the brackets are telling us that we have to raise what's in the brackets to the power of 4. So that 4 is going to remain there, and we're going to have x to the 2 times 4, which is 4x to the 8. Okay, so be careful of those brackets. Now, thus far, or so far, we have looked at questions or exponent laws that take one base into account. What happens if we have more than one base in the bracket? Okay, or one unknown base. Okay, let's look at that. So if I had a times b to the m, okay, this we would have to remember here, the exponent is 1, the exponent 1 is here. This becomes a to the m, b to the m. Both are raised to the power of m. Okay, let's look at an example of that. If I had, let me draw that bracket neater for you. If I had x squared y cubed raised to the power of 6, okay, I would have to raise both of these to the power of 6, both the x squared and the y cubed. So this becomes x to the 2 times 6 times y to the 3 times 6. And thus our answer would be x to the 12 and y to the 18. That is our answer. All right, so this is the situation where we are actually multiplying unknown bases, or not unknown bases, but different bases. Okay, if they were the same base here, we could use exponent law 1. Okay, let's look at that. Let's just say, for argument's sake, that instead of having x squared y cubed, we had x squared x cubed times x cubed. Now, can you see that the bases here are the same? And thus, our first exponent law comes into effect. And if our first exponent law comes into effect, I can add these two exponents. Whoopsie. So this becomes x to the 2 plus 3, which is 5. And now I can raise that to the power of 6. And remember, I multiply these two out. So this is x to the 30. Okay, let's do the next law. The next law is where we have a fraction So if I had a over b raised to the power m, I have to incorporate or apply this multiplication of this exponent, the m, to the exponents in the bracket. Okay, so therefore this becomes a to the m over b to the m. We can't leave any of these spaces out. We have to include everything. Okay, let's do an example of that. So if I had x squared over y cubed squared raised to the 2, I'm going to multiply that by 2 and multiply now the y by 2 as well. This would become x to the 4 over y to the 6. Okay. And what would happen if I had, as well as a base, but I also had an example where I had a number? So let's look at this. If I had 2x to the 3 over 3y to the 4. Now let's raise this to the power of 3. Do you notice that the 2 and the 3 are also in the bracket and they're part of the fraction? So we have to raise them accordingly. They are also part of the story. We can't leave them out. So 2 to the 3 is 8. And then we multiply exponents. 3 times 3 is not 6, it is 9. Okay, common mistake with students. 3 to the 3 is 27. And y, 4 times 3 is 12. So this becomes our answer. Good. Okay, let's continue. Let's look at some of these definitions that we have. They are also laws, but we call them definitions because two of them are, or three of them are definitions. The third one can be seen as a law as well. Anyway, just know that you have to know them. That's what it boils down to. So a to the n is the same as a multiplied by itself to n times. N is the number or the exponent. So if I had a to the 5, it means that I multiply a by itself 5 times. This is the same situation if I have a number. 2 to the 4 would be 2 times 2 times 2 times 2. Okay, this would be 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. So don't forget that. Our next law is pretty simple and very easy and very convenient. And it will be coming up again and again all the time. And that is any base to the power of 0 is equal to 1. Okay, when we do functions, we will explain. I will explain to you why this happens when we go over the exponential function and exponential graphs. So if we have 532 to the power of 0, it is equal to 1. Anything to the power of 0 is equal to 1. Pretty simple. The next law deals with surds. Okay, so a surd is, a surd, S-U-R-D, also called a root, is this little device, mathematical device. Okay, if there's no number in front of the surd, we take this to be a square root. Like you know that the square root of 4 is equal to 2. It's actually equal to 2 positive or negative 2. Because negative 2 times negative 2 is equal to 4. And 2, positive 2 times 2 is equal to positive 4 as well. So that's what a surd is. But anyway, our surd law states that if we have a number and a base or a power, x to the m, and we are finding the nth root of it. So this number can be a 2, a 3, a 4, doesn't matter. We treat the surd or the exponent as follows. This is going to be x. The m stays there, and we actually divide it or represent it as a fraction. So the n then goes to the bottom. Okay, so let's look at an example of that. If I had x to the 3, and we were going to find the cube root of x to the 3, this would become x to the 3 over 3, which is equal to x, or x to the 1. All right, if I had x squared and I was trying to find the fourth root of that, okay, the fourth root, this would be x to the 2 over 4, also simplified to x to the half. We had a number that would also work if I had to find, let's say we had 27 in here, and there was a cube root of 27. Remember, when there's a number here, all we have here is a 1. So this would equal 27 to the 1 over 3. Now, it just so happens that 27 is the same as 3 to the power 3. So I can represent 27 as 3 to the power 3. And now can you see how our third exponent law is coming into effect? The one that states a to the m raised to the n is equal to a to the m times n. So what are we going to do here? Yes, multiply these exponents out. And that's going to leave us with 3 to the 3 over 1 times 1 over 3, which is the same as 3 to the 3 over 3, which is the same as 3 to the 1, or 3. And that is why the cube root of 27 is 1. Sorry, the cube root of 27 is 3. Because this exponent, using this law, simplifies to 1. Then our last law is very handy, and it's the law of reciprocals, or the inverse law, that states that a to the negative n is equal to 1 over a to the n. Remember, this can also be represented as a fraction. What this law allows us to do is shift or transpose or transfer or transport our powers on either the numerator or the denominator. Remember that in a fraction, if I have a over b, that this number at the top is referred to as the numerator, and the number at the bottom is the denominator. Okay, I'm going to be using these terms when we deal with fractions. Okay, and now that I've brought it to the bottom, can you see that the exponent is now positive? So a lot of these questions, actually all of these exponent questions, we have to leave our answers as with positive exponents. And this law, or exponent law, allows us to do that. So maybe in the final step of an answer, we end up with something as a to the minus 2. That's great, a to the minus 2, but we, as mathematical etiquette and manners, out of having good manners, we say that we'll take this to the bottom and leave our answer as 1 over a squared, because we want to make sure our exponents are positive. Similarly, if I had x to the minus 3 over y to the minus 4, I can take this to the top, take that to the bottom, and I can end up with an answer that allows me to have positive exponents throughout. Okay, so it's a nice little trick and a tool that we have. And you will see when we do the factorization and the other questions that we're going to be using this law so many times to make our lives easier.